Welcome to this video where we will be covering Introduction to Fundamental Concepts in the R programming language. The agenda for this video is that we will be introducing some fundamental R concepts and subsequently taking a look at some data structures that are commonly used within the R programming language. R as a programming language was developed in the early 1990s. As such, over the last 2 decades and more, it has seen a substantial evolution in the structure of the language and the ways it has been used. Fundamentally, R was developed as a vector-based language and not a procedural language. One of the big challenges when working with data is performing simple operations on collections of data like arrays required a lot of procedural code that allowed individuals to, for instance, add multiple arrays together, subtract arrays from each other, and perform other mathematical operations on collections of data elements. R as a language was developed as a vector-based language, or a language that allows us to perform mathematical operations on data structures that have multiple data elements in a very simple, straightforward manner. This made R a very powerful tool specifically to work with data structures that hold multiple data elements. Consequently, R as a programming language was used specifically to manipulate big sets of data and generate graphics and visualizations from those large data sets. Within the R framework, all elements in R are considered as objects. Object manipulation takes place through the use of function calls or built-in pre-programmed pieces of code that allow us to perform operations on specific individual data elements or collections of data elements. There are a variety of ways that one can write R code. One can write R code at the command line. One can write R code by running a source file that holds the R script, or one can use a graphical user interface to run R code. R supports a variety of different data types that can be manipulated. R supports numeric, character, date, and logical data types. Numeric data types includes whole integers, but also other decimal numbers, long numbers, so on and so forth. A variety of different characters can be represented within R, and character data types are specifically enclosed in either single or double quotes. R also allows us to create and manipulate date-time data. And R also supports logical or Boolean data types, specifically true-false values. There are a variety of different data structures or containers for individual data elements that are supported within R. As mentioned earlier, R is a vector-based language, and so the fundamental data structure supported by R is known as a vector. Vectors are a type of data structure that hold same type elements. That means that every element in a vector needs to be of the same data type. Another data structure supported within R is that of matrices. A matrix is a rectangular container in the sense that it has 2 dimensions. Matrices also support same type elements in the sense that data within a matrix has to be of the same data type. Data frames are a type of data structure supported within R that are very similar to what we might find in Excel tables. Data frames are many vectors of the same length. This means that a data frame can hold data of multiple types within each individual vector, but each individual vector has to be of the same length. Other data structures supported by R are called arrays and lists. An array is a vector that has multiple dimensions, and a list is a type of data structure or container for elements of multiple data types.